Welcome to this video lecture on the subject electronic circuits. So in this lecture we are going to discuss about common emitter amplifier and H parameter model. So let's see the basics of common emitter amplifier. So for amplification we need a transistor circuit. So where we are giving a weak signal, typically less than millivolt or microvolt. So it amplifies the signal, that is it increases the strength of the signal. For example, loudspeakers. So we are giving a small signal to the loudspeaker and it amplifies the signal and it gives the output. So this amplifier needs the biasing circuit. So for this we need a common emitter configuration in the voltage divider bias circuit. So first of all, it works by small base current to control the large collector current, resulting in larger output voltages. So this uses the common emitter configuration to amplify the given input weak signal. So here the circuit of the common emitter amplifier is shown, where the transistor, NPN transistor, is connected. Input signal is the AC signal. So this input AC signal is connected to input coupling capacitor and it is applied to the base terminal. As we are using the common emitter configuration, base is the input terminal, collector is the output terminal, emitter is the common to both input and output. So it is common. And biasing is that voltage divider bias is used for this configuration and VCC is connected to R1 and RL. So in this common emitter amplifier we get a high gain for the given input signal. So and also the next characteristic is 180-degree phase shift. So due to this, input and output are out of phase by 180 degrees. So inverse of the input. So input and output waveforms of common emitter amplifier are shown. Can you guess why the output is inverted version of the input waveform? So here output signal and input signal are 180-degree out of phase due to the voltage drop at the collector terminal and working. So how amplifier works? Here the AC input signal is applied to the base of the transistor. So it causes small variations in the base current. So transistor current gain beta amplifies the small changes in the base current to much larger changes in the collector current. So we know the relation between collector current and base current. So IC equal to beta multiplied by IB. So this amplified collector current flows through the collector resistor, creates the large voltage drop across it. So this voltage drop is the amplified output signal. Next is the phase inversion. C amplifier introduces a 180-degree phase shift between input and output signal. So when input signal goes up, the output signal goes down and vice versa. Next is the voltage gain. It is the very important parameter. Here the ratio of output voltage to the input voltage is the voltage gain, which is high in the common emitter configuration, so that it is the mostly used configuration for the amplifier. Next we shall discuss the H parameter model. So it is the important parameter. It is known as the hybrid parameters used for analyzing the small signal amplifier circuit, where we are giving the weak signals to the transistor circuit and it is amplified. So this amplifier circuit can be redrawn using the H parameter model to analyze the gain, impedance, input impedance, output impedance values. So here H11 in this equation, H11, H12, H21, H22 are the hybrid parameters which can be used to analyze the gain and impedance values. So for BJT, it is a two-port device. So by applying the H parameter value, we can get the H parameter equivalent circuit. So here base is the input terminal, collector is the output terminal and emitter is common. So for this circuit, we are going to draw the H parameter. So here HIE is the input impedance and it is connected to base, and HRE is the reverse voltage ratio and HFE is the forward current transfer ratio. So and H naught is the output admittance. So for this high H parameter equivalent circuit is shown in this diagram, where VBE and IC are written using the H parameters. So this is the comparison of three configurations for the common base, common emitter and common collector. For each of the configuration, input impedance and current gain, voltage gain and output impedance admittance values are given. So this is the H parameter equivalent circuit using the HI, HF, H0 and HR values. Let's take the assessment, list the advantages of CE amplifier and derive the H parameters of common emitter amplifier. Thank you for listening this lecture.